I'm Preslav. I'm based in Bulgaria, Sofia, so same time zone as Israel. I guess most of you are in that time zone. Really happy to be here today on GopherCon. This is actually my first GopherCon appearance in the GopherCons out there. So really happy that it's happening in Israel. The thing I'm sad about is that it's online, not on site, so I don't have the chance to meet you all live. But if things go well with the situation we're all in right now, hopefully next year I'll be able to meet you. Regarding me, I'm a software engineer at Uber, and we're developing microservices in Go and Java. And we use gRPC extensively. And today I wanted to make this workshop about it called, hands-on gRPC with Go. And the thing which I want to emphasize is that it is hands-on, not, ears on or eyes on. It's meant to be practical, and the hands which are I was intending to focus on is not my hands but yours. So it's going to be a very practical session where you're going to be able to try out what gRPC is for yourself, and you'll be able to see how it all works, and in the end hopefully evaluate whether it makes sense for your own organizations, own projects, and you hopefully have the skills and knowledge to make that decision. The workshop is going to be focused on the practical side of it. It's not focused on why we need gRPC or what are its caveats or how it compares to other communication protocols we have out there. Although I will briefly discuss that just in case you have no clue what gRPC is at all. But I won't focus on that because there's enough material out there which you can later read on to get familiar. But no matter how many blog posts and YouTube videos you can go through, it's not a substitute for actual practice. And the aim of this workshop is to bridge that gap and provide you opportunity to gain sufficient practice. All right, then. So I discussed that today we're going to be talking about gRPC. Now, I already mentioned some words about me. If you wanna get in touch, feel free to find me on Twitter, or you can also check out my website where I write some blog posts lately about Go. And I also have a GitHub, LinkedIn. I'm sure you might be able to find me out there. Okay. And the agenda for today is, as I mentioned, we'll briefly cover some basics of gRPC, what it is about. We'll cover what features it has, but the most prominent time we'll spend on the fourth point, which is getting your hands dirty with gRPC. Now, before we start, I'd be really happy to spend a few minutes to get to know you a bit. So, can anyone who is willing share a bit more about what's your experience with gRPC? What are your expectations of the workshop, and how I can help you in that regard?
I can say something. So I've read about gRPC before, but never actually really done anything substantive with it. So it's a good chance to get my hands on.
All right. Nice. Okay, glad to hear that, Max. I think that, in case you haven't tried it out before, I think it will be a good opportunity. By the way, also one thing I just recalled I should share first is that I have this document which I want to share with you. I think you should have received it by email already. If not, I'll share it now, which is just some environment setup things which you should go through. And if you are regularly developing in Go, I think it shouldn't be a huge issue. So you can take the opportunity to go through it now in order to spend the most time later not setting up environments, but actually writing the code. Cool. So let's proceed now regarding back to the topic of gRPC. So at its core, it's a communication protocol, meaning that it serves the purpose of connecting different web applications which want to talk to each other. There are other communication protocols out there like REST, which I'm sure most of you should be familiar with. You know, we have GraphQL nowadays. Previously, there were SOAP and similar protocols. And gRPC is yet another protocol like that. Its main selling point really is that it's quite optimized. This is not the only one, but it's quite optimized and for communicating. You can check out some benchmarks if you want after the workshop if you're curious to see actual numbers. But that's one of the main use cases for it. And if you have a huge microservice environment, that makes a difference. Those kinds of little things because transport cost when you're communicating with other services is not zero, although we often assume it is. It isn't, and this is one of the verticals on which we might choose to optimize our traffic. Okay. Now, some other quick things to note, which if you've read a bit about gRPC, you might have heard. It's based on HTTP2, so it uses HTTP2 exclusively. So the fact that it uses HTTP2 already gives it an advantage over REST when it uses HTTP 1.1. Now it is possible with REST to use HTTP2. That's perfectly viable. But this is not only, although that makes REST clients faster and servers faster. That's not the only thing which contributes to its performance. The other thing which is cool about gRPC is the fact that it uses this thing called protocol buffers, and you can think of those as the JSON of gRPC. So you have gRPC, which is the protocol by which communication flows between two parties, but you still have to define what the data format is. And for REST, that data format is defined by a JSON. In gRPC, there are these things called protocol buffers, which you will get your hands on. And what a protocol buffer is essentially an interface definition language. So it's something which involves you writing a schema for the data you want to communicate between two services. And based on that schema, you compile it to some code which you can use in your favorite language, assuming that's Go for most of you here. To give you a visual representation, imagine that this is a file you write which just defines some interfaces. It says that you have some service which has certain routines you can invoke with parameters, and those routines return some data, some result, which also has a type. You can use types like string, integer, data, and whatnot. JSON, it's not typed. You don't have types like that. The schema is not explicit, but in protocol buffers, it is. And from that schema you write, you use a program called proto-C, which takes the file and compiles actual source code from it. So you can imagine it like some generated code, which you plug into your application and use out of the box. And in the end, in the eyes of the developer, it looks like you're calling normal functions, normal Go functions when you want to communicate with a certain web application. But in reality, that function underneath makes an actual call over the wire, over the network, and invokes some routine or on the distant server. I won't go into too much details here because you will get a chance to actually write those things. So you will get a chance to explore it on your own. I'm really anxious to get to that part of the workshop. So for now, I will leave. It's normal to not everything to be certain right now, not everything to be understood. That's perfectly fine. You will get a chance to do it, and there's also going to be time for questions later. Now, some stuff about comparing gRPC and REST. One of the differences is that gRPC uses these things called IDLs, interface definition languages. In this case, via protocol buffers, you define a schema from which you generate the code and you use it. In REST, out of the box, you don't have that, because when you have a REST server, you have to write some kind of a client in your, let's say, front end, which understands what endpoints to invoke. It understands how to pass the parameters. It understands how to validate them, etc., etc. That's what you typically have to deal with when you use REST. In gRPC, you don't have to do that, because you have auto-generated code for you, which has that types and has that knowledge about what you can invoke out of the box. Now, you have something similar in REST you can put on top of your API, which is OpenAPI or Slugger, but it's more of an afterthought than a native thing which comes with REST, with the REST protocol. In gRPC, it's native. It's meant to have this interface definition language. In REST, you can use a tool which kind of generates some code for you, which unfortunately is not as easy to use in my experience than let's say gRPC generated code is. Okay. Another caveat when you compare gRPC and REST is that, so gRPC uses protocol buffers and REST uses JSON. And one of the differences there is that protocol buffers have a schema, and you use that schema to generate code, while REST typically uses JSON, not necessarily, but typically uses JSON. And the difference there is that, protobufs have schemas, but the other important thing is that they are more compact than JSON, meaning that protocol buffers, when you transmit them, you don't transmit them in plain text. They are actually encoded in binary form, making them giving you the opportunity to transmit the same amount of data in less bytes, in less data frames, let's say. That's one of the contributors to the performance of gRPC, because when you have a lot of data you want to transmit, let's say if you transmit it via JSON, you might take, for example, 100 megabytes of bandwidth. With protocol buffers, that would be reduced to 60 megabytes, for example, out of the box. Okay. However, this doesn't come without a cost. The cost of using this is that with protocol buffers, obviously it's in binary format, meaning that it's not understandable to a human. It's harder to, let's say, trace your network frames, trace the data you're sending over the wire and understand it. Because you might intercept your network calls, but you just see a blob of data which you don't understand. With REST, since it's JSON, since it's plain text, it's way easier to debug and understand what's actually going on. So there are always these trade-offs. And all these things I mentioned so far, the fact that gRPC uses protocol buffers, REST uses JSON, and the fact that gRPC is typically based on HTTP2 attributes to the fact that gRPC is, in general, summing all things, and all things equal faster than REST. But the huge advantage of REST and why it's still used nowadays is that REST is still supported by all browsers, while gRPC is not. With gRPC, you don't have browsers which use HTTP2 out of the box yet, like not all browsers do. And you have certain workarounds around that. So there's this thing called, let's say, gRPC Web, which is some kind of a proxy which allows you to use gRPC over HTTP 1.1, giving you more compatibility with a lot of browsers, but that also has a cost associated to that, because that strips away some of the functionality which you can achieve via gRPC. And what I mean by functionality is the different kind of communication flows you can use, which we'll get to a bit later. I've also linked several articles throughout this slides, which you might have noticed at the bottom here. I will share you the slides after I finish this and provide you the rest of the materials, and you can check them out later. Okay, and if I have to summarize, this comparison, there is no silver bullet, like gRPC is not the answer to everything. And nowadays, the typical rationale is that gRPC is more suited to server-to-server communication, while REST is more suited to your front-end gateways, your front-end clients, because it is, although it's not as performant as gRPC, it is more compatible with more clients, like more browsers, for example. And of course, this is very simplified. There are a lot of intricacies, a lot of caveats you have to factor in, but this is just a simplified version as a takeaway you can use, a tweetable takeaway, let's say. But definitely don't just use this as a decision maker when you decide to make a transition to gRPC. Definitely do your research on your own as well. This is just a brief summary and introduction. Now, in terms of the features which gRPC provides, this is another selling point for gRPC. So far, we've just compared performance and certain, let's say, only the data format and the performance. That's what we've discussed so far. One more thing which gRPC provides is a lot of native options for communicating, which you see right now. One thing which we already went through is the fact that with gRPC, you can use a schema definition language or interface definition language. You can write your schemas just like you write database schemas. And from it, you can generate code you can plug into both your clients and your servers. That's one of the things which you actually go through later. You have the typical way to communicate between servers, server and client, which is with a request response model. This is something which is also available in REST. It's available in gRPC. Nothing new so far. However, the big thing with gRPC is that it also has 3 more types of communication you can use, which are very useful in certain cases and which you have support for natively. These types of communication you could achieve with REST and other communication protocols, but it's not native. You have to use certain hacks or workarounds, or you have to supplement your clients with different protocols to achieve it. One such thing is unidirectional streams, and there are 2 types. You have client-side unidirectional streams, where you can have a client send multiple requests to a server, and the server generates a single response for you. You also have the opposite version of this, which is server-side streaming, where you have one single request and multiple responses back to the client. You might have encountered this in your experience as well. Typically in typical REST APIs, it's achieved via pagination, but it's not necessarily the same. It's more of a hack to achieve this, where you have a request, you get a response, and you make a subsequent request again to get the next response. But in gRPC, you can skip this overhead of new TCP handshakes and new requests. You can have a single request which initiates multiple responses one after another, and you actually experience this on your own, and you get the chance to try it out for yourself and see how it works. I'm not going to discuss in detail use cases for these kinds of communications right now. If you're curious, ask me later, and I can tell you certain use cases which are cool for these kinds of communication flows. And the final thing is bi-directional streams, where it resembles a something like a chat, where you can have the client send multiple requests and the server send multiple responses. And these not necessarily have to be in this order. You can have a request, 2 responses, and a request back, and etc. They can be intermixed. I just drew it that this way because it has to fit on the slides. But this is an opportunity to support something like a real-time system, which has to provide data on demand rather than using other kind of hacks such as polling to achieve that. Okay. And now's the time to actually see these things in practice. Again, I didn't provide any code examples so far because you will see the code examples and write them for yourself right now. So to conclude this part of the workshop, a simplified comparison between gRPC and REST is that gRPC is useful for inter-service communication, and REST is more appropriate for front ends when you have your gateways with the external systems. In gRPC, you have this interface definition language via protocol buffers, where you write your schema, generate the code, and you reuse it across your client and server. And it supports 4 types of communication, the typical request response model, client-side streaming, server-side streaming, and the final one we observed, which was bi-directional streams. And this concludes the theoretical part of the workshop. And now is the time, if you have some questions, we can briefly address them before we move on, and I share you the materials for the rest of the workshop. Okay, so any questions from anyone?
Maybe I have a question, but we can also answer the question at the end of the workshop if there's some time. Because my intention is to convince people in the company to choose the option of gRPC instead of a conventional REST API system for server-to-server communication. And then if you could say at the end some more plus points for gRPC instead of conventional REST API. All right, nice. I wrote this down. I'll get back to you during the workshop. We can discuss this more. Thanks for asking this. Thank you. Right. Anyone else? All right then. So if there aren't any more questions, first have in mind that this is a bi-directional stream between us, so you can ask questions anytime and I can answer it anytime. Feel free to unmute and shout out. I'm not going to leave now. But I think we can conclude the formal part here, and I can provide you the materials and walk you through them. Okay, so in terms of the materials, here's what we got. We have 4, you can consider them exercises, which you can go through one by one. And you have one document which just outlines at a high level what we're building. Can you, by the way, hear me? Because, okay, you can. For a second there, I didn't see the microphone moving. In this document, which I'll share with you right now, this is just a description of what we're building. You are free to actually skip this, but it might be useful if you just want to get a high-level overview of the end goal we have. You are going to achieve it either way, even if you don't go through it. This will just give you a nice summary of what's ahead, and get you pumped up for the rest of this stuff. It will show you the final thing we're building, which is this set of web services which communicate with one another. And they support certain operations. So here you can see a GIF I've uploaded where from your client, you're sending certain commands to your servers and they execute them. We won't go into the details of the command right now, but I've outlined what's ahead here and what kind of kind of routines you have supported. And throughout building this, I've set it up in a way so that you can explore all the different communication types. So you have typical request response routines, but you also see examples of client-side streams and server-side streams. And also finally, you have an example of a bi-directional stream so that you can see all examples of what's ahead. And you can, experience everything, let's say. Okay. Can someone just confirm if you can open the document and everything's okay? The one I just shared in the chat?
Yep.
Okay, cool. All right, and then I'll share with you the next 4. And after I share them, I will walk you through what to expect in those. Okay, and if I miss someone or misclick some of the links, just let me know. I'll send you the correct link. Okay, so these are the 4 documents. Feel free to open them in different tabs. And this is the presentation, which is more of an FYI. You won't really need it throughout the workshop. You can check it out later, just if you're curious about some of the links. All right, so this document outlined what we're building. And these documents are all structured in a similar way. They follow the same structure where you're building a certain part of the whole system. The first part is creating the schemas via protocol buffers, generating the code for those schemas, and writing some initial boilerplate you need in order to set up your client and your servers. In the beginning, you find instructions about how to get the code, which is the starting point, how to install dependencies, which you should have already done if you went through the prerequisites. If you haven't, do check it out, because otherwise you will have some of the tools missing and you will stumble upon some of the points throughout the workshop. Then you have an explanation of what we're going to achieve with the current exercises. And here we're explaining where the different parts of the systems live and a brief summary of what those are. For example, we have 3 folders called Casino, Client, and Payment Statements. They all have the source code for different web services. The client is the only thing which is not a web service among these 3. You have other descriptions about where everything is. Have in mind that this is duplicated across all the 4 documents. And all the documents are written in a way that they are independent from each other. Meaning that if you are not interested in, let's say, learning what a service schema is, how to write one, if you're not interested in writing protocol buffers and exploring those, you can just skip ahead to the next parts of the workshop, which is, let's say, basic RPC routines or bi-directional streams, if that's what catches your eye. You don't necessarily have to follow it in order, but if this is the first time you write any kind of code with gRPC, I do suggest you follow it in order. However, this is just a convenience I've done in case first you're not interested in the whole workshop, only parts of it. And second, if you stumble upon certain points throughout the workshop, let's say you get to the 3rd part, but there's some missing piece in there you've forgotten or you've missed and the code doesn't work for some reason, you can just proceed to the next exercise without getting blocked. So that's also another use case for following these patterns. All the starting points for the different exercises reside on different branches, which you can clone and start from there. But you also have the option to start from the beginning and get to the final branch without cloning anything else. All right, and then you have this, let's say, shortcut you can take where you can choose to go to a section called full walkthrough. What the full walkthrough is a step-by-step guide on how to complete this part of the exercise. If you're not interested in trying out stuff on your own or exploring certain things on your own, you can go to the full walkthrough and just either copy paste the code there, which is given, read the explanations, and go step by step, and you should be fine throughout the whole workshop. But if you are more adventurous and you want a bigger challenge, you want to explore certain parts on your own, here you have details about what you have to complete. And these details should be sufficient so that you can take it from the beginning and get to the end without sufficient help by peeking at, let's say, the final code for this exercise. However, for the purposes of this workshop, I do not recommend this path. I do not recommend, attempting things on your own. And the reason is that we won't have enough time this way to cover everything. Actually, you won't have enough time to go through everything. And if you just go through the full walkthrough, you will have sufficient time to complete the whole workshop. While if you attempt this on your own, you probably get to, let's say, the second or third document, and you will have to finish the rest on your own in your own free time, which is also an option. I'm not going to prohibit you from accessing these documents after the workshop is done. If that's what you prefer, go ahead. That's perfectly reasonable. But if you want to, just keep what you're doing here in the confined to the workshop time, then go through the full walkthrough and skip this section where it's more challenging. Okay, cool. Now, in case you do want to challenge yourself, I've left these two links here you can use as a reference on, let's say, how to write protocol buffers or how to write gRPC code from the official documents, but you also get to learn this by going through the workshop. All right, so that's the initial briefing I wanted to share with you. And you feel free to start. I assume you've already started, which is reasonable, given that we have only 2.5 hours left. Depending on your experience, it might take less, it might take more time, but it's up to you. And throughout the workshop, if you have something where you don't know how to do, or you don't know why certain thing is written that way, or you have some kind of a coding error you can't resolve on your own, feel free to ping me, and I'll just let you share your screen and go through the problem together. I'm here for support. But in general, this should be a self-paced workshop where you can go through it on your own pace, and it should be self-sufficient, and you should be able to get through it to the end. I know that because I tested it a lot beforehand. I made sure that everything's working, and you shouldn't encounter any huge roadblocks. The only thing which is more challenging is in the first document, where you have some platform-specific differences. For example, if you're using Windows or Linux, you might stumble upon certain things which I haven't foreseen because I use a Mac, and perhaps on my platform it might work, on others it might not. And if there are certain cases like that, don't waste time trying to solve it on your own. Just ping me and I'll see what I can do. Or if you do find a bug like that or an issue and you are able to resolve it, please share it via comment here in the document so that others can benefit from your troubles and can avoid spending the time you did to fix the issue. That would be really helpful. In previous workshops I've done, I followed a similar pattern, and actually participants were really helpful back then in unblocking the rest of the people, including me, because I didn't have a clue about what was going wrong, but someone was able to figure it out. And when they shared it, it was a great relief for everyone. So have that in mind. Okay, questions from anyone? I see Dima shared that there is no such flag for their command. I think this happens because you haven't updated to the latest version of Pro2C or the plugin for Go. Could you attempt doing that if you had installed it before this workshop? I know that this require unimplemented servers flag you're mentioning really is a new thing in one of the recent versions of either Pro2C or the Go plugin. So you have to update to have it. Okay, great. So everyone's silent and working. That's great. In that case, I will mute myself and stop wobbling around so that you can work in silence. And if you have any issues, feel free to write in the chat or unmute yourself. And I'm around. We're around the end of the workshop. Have around 40 minutes, but depending on the progress of everyone, we might choose to dedicate some time to discussions in the end. So let's see where everyone is. If you're seeing this for the first time, just go to slido.com and write that ID you see there at the bottom left to join this poll and answer it. I see that someone is still in on part 2. Are you encountering any issues there, or is it just the pace you're going with? Do you need any help with part 2? Whoever answered that.
Yeah, that was me. No, all good. Just a pace.
Okay, cool. All right, it seems that would be the peak of answers so far. Still, I think we're pretty much on track. Whoever is, most people are on part 3. My expectation is that by 4 p.m. you should be done with part 4. So we're going good. One thing which I'm wondering if you guys would like to dedicate some time in the end for discussion about gRPC and whatever questions you have, or would you like to fully dedicate whatever's left to go through the workshop in silence? Like, what do you prefer? Anyone willing to share? Let me check out the chat as well. Nope, nothing in the chat. Okay.
I think maybe it's better to talk more about the streaming. So how gRPC is matching streams, because in source code I see that there is no specification of any kind of ID how is the stream is being handled inside. So for example, in Gamble we have Bi-Directional Stream. Okay, so you see in generated code we have server stream and client stream. Okay, how gRPC is matching this? So this client stream is supposed to go to this, let's say, stream and not other. If we will, for example, serve multiple streams.
Yeah. So. All right, so I guess you're asking how does the connection between the client and the server stream happens, opposed to how streaming is implemented internally in gRPC, right? Or are you curious about that as well?
Yeah, both.
Okay.
So first, let's start maybe from more high-level design, how it's being connected and how it's implemented.
All right, so from a high level, let me See what branch I'm on. Okay, so I'm at the final branch. So from the client in main.go, somewhere around here, the bidirectional stream should be handled. Yeah, it's here. Okay, so whenever you invoke client.gambo, and client is a reference to the gRPC client you have, an instance of it, what you get returned is a stream object. And on the server side, if you go to, I guess, Gambo somewhere, yeah, here, this function automatically gets invoked whenever someone, well, executes this piece of code. So whenever someone invokes Gambo, on the server, you get this function automatically invoked, just like you get some functions with REST invoke whenever you make calls to certain endpoints. It's handled by the framework. And what you get as a parameter is this stream, but this is the server stream, while on the client side, you get a client stream. So this is of type Casino Gambo client. And anytime someone makes a request to you, you get a new stream created exclusively for that caller. So when I make a call to the server for a Gambo, and if someone else makes a call to the server for the same routine for Gambo, on the server side, you get this function invoked twice in two different Go routines, you can imagine. And you have two different instances of this stream. So it's not reused. It's actually confined to the, the request which you're currently handling from the client. While on the client side, there's not, you could also even on the client side invoke this multiple times in, let's say, a for cycle, which spawns Go routines. You can make several requests at the same time. It's perfectly fine. And the streams you will get will again be totally distinct, and you will, they will be their own independent thing. So there's no overlap between the streams. So that's that. Now, technically you could, for example, implement some kind of middleware that's perfectly possible, which caches certain results. It's totally doable. So you can, in your server, you can instrument certain middleware, which, let's say, for a given request with the same data, if you've already calculated that data, you can just return it. No need to calculate it again. You can do something similar for streams. But that I really haven't checked if you have any library for that out of the box, but implementing one yourself is perfectly doable. So it's fine. You can do it if you need that. So that's in terms of how streams work at a high level, like how the client connects to the server and how they start the streams and work with each other. In terms of how the stream works, how the stream, primitive is handled by gRPC. So one thing which is a given when you use gRPC is that you use HTTP2, and HTTP2 gives you certain capabilities which you don't have with normal HTTP. One such capability is server push, which is actually leveraged by gRPC to implement, let's say, server-side streams and also bidirectional streams. Now, this is not a good resource because I was hoping for something more visual. Nope, not this one. Well, okay, maybe I can just use my slides. This is the graphic I gave you for how a server-side stream works. With HTTP2 server push, that feature of HTTP2 uses the same concept. You make a single request, and inside the same TCP session, you can send multiple responses. So that's how typically gRPC handles streams like that. Now, there might be some intricacies when you have bidirectional streams about how you can enable, the client and the server to send requests and response simultaneously. That I'm not entirely familiar with all the specifics of HTTP2, like what constraints it gives you. I think it will probably use something similar, but in a nutshell, like the main concept is that you're reusing the same TCP connection, and within the same TCP connection, you are exchanging multiple requests and response, which enables you to avoid multiple handshakes and multiple opening and closing of the session. So that's I think that's a nice way to summarize it. Does that answer your question, or do you have any follow-up?
Yeah, more or less. So basically, in this case, so this stream will remain open unless we will get explicit request to close it.
Yeah. Or unless the server has some kind of a timeout, you can set a timeout or even control it like via your application. You can just send an error back or whatever you want and close the stream. So for example, in the casino here, in this case, I'm iterating the stream here, and I can just at some point invoke close and receive or close send, depending on whatever kind of logic I have. If, for example, I'm busy, I can't handle the request, you can directly close the stream, even if you're in the middle of it. So you have a lot of control here. You can either decide to close the stream yourself, both from the client and the server, or simply set some kind of a timeout where if the client doesn't respond to messages, you time out and stop the session.
So basically there is some kind of background ping to client or what? So for example, on server side, I want to know if there was a connection loss. So is there a way to send some kind of background ping to handshake to a client, or is it done inside of this stream already?
Yeah, so give me a second to try to find something. So stream.send, for example, it gets an error back, and this error can be lots of stuff. Now we should probably check what kind of error types we have. So go gRPC. Let me just find the Go doc for gRPC. I think I had it previously, but I closed it at some point. So reference and documentation. All right. Yeah, you probably get this error back, transport is closing, if there's some kind of a connection loss. I'm just not sure if you have certain error types you can, let's say, check against. Yeah, okay, don't see anything out of the box for it, meaning that probably, well, I guess in this case, what you could do if you wanna type switch your errors, if you, let's say, want to have something like error, and you wanna check if error is, transport closed or anything, you can either use, if you don't have anything out of the box, you can either check the message which is returned, whether it contains transport closing, or you can, again, add some kind of middleware which translates your errors into your own user-defined types, user-defined errors, based on the same logic, essentially.
So basically, we're using a little bit of gRPC, and so what I try to do is I try to use get a status from error, okay, in gRPC, and in most cases it's just got a code unavailable. So, but it doesn't mean that, as far as I understood, it doesn't mean that we got connection loss. So there is no way to check that it was actually connection loss or just.
When did you get that code unavailable? What did you do to receive it?
Basically, so in most cases, I faced it, for example, on the first request from gRPC client to a server. And if I do just a retry, in most cases, it is okay. But it's not only the first time, so it's getting from time to time, let's say. It's not persistent.
I see. It does sound like some kind of a network error. I mean, I think that, I think that you might find some info about what the different error messages mean. Definitely not the only kind of error you can get. So here you probably got code. What was it again? Unavailable?
Unavailable, yes.
This is probably what you got. So some kind of a transient condition, which you can try with a backoff. But you have all sorts of other errors. I guess, yeah, you can use these numbers, which you have the status codes, to check the specific error you got, or you can also use the message, but I think the error codes are more reliable. And now I'm not sure why you did get this on your system. I can only guess there's some kind of issue connecting to your other server via localhost. But yeah, this is.
So it's not always localhost.
Mm-hmm. So you did try to connect to a distant server?
So yeah, basically we have it deployed in AWS, so server on one machine and client on another one. And
yeah, that's definitely something which can happen from time to time in that kind of deployment. And are you asking how you could address that, how you could handle it?
So the problem is the reason of this problem is unknown, because just a simple retry works.
Yeah. I mean, that's so I think that's the right thing to do, and probably one of the only things you could do, because network failures happen from time to time, and reasoning about why they happen is often really hard from a developer standpoint. I mean, if you're a system administrator or you have some privileges to access the logs of your server instances, sure, you can go and inspect what went wrong if you're quite advanced in networking there. But from a development standpoint, really retrying is often the best you can do.
No, but in case, okay, this is okay if it is just a simple query. But in case if it is a stream, so I assume the stream is being closed after getting this error.
I see.
And in this case, you will start streaming from the beginning. So it doesn't have any kind of saving a state.
Yeah. So your retry mechanism, how are you doing it? Is it from your application itself?
No. So currently, it's not a streaming, it's just simple request. And yes, it's just sending the same request again.
Yeah. So one thing you can check out, I think if you attempt to do this retry from your application side, you might not be able to recover the stream once it's unavailable. But one thing you could try is, I did share somewhere in the chat here, this collection of middlewares. And one of the middlewares was gRPC retry, this one. And I think you can leverage that to try to recover your ongoing streams. I mean, if this happens at the middleware level, not at the application level, I think you have more control over the request you're making. You have other alternatives as well, like gRPC recovery, but I think it's worth trying to experiment with this one.
And also another question, so both client and server will get the same error? Or is it any kind of delay?
Well, it depends on the error. Like in the case of the error we were looking at, probably yes. Probably you get the same error. But if it's something else, it's pretty context-based. For example, not found. I'd say that this is something you might encounter it, let's say, from your client, but your server might not necessarily get the same error, or they might not even get an error at all if you, let's say, messed up the gRPC server itself.
So basically, because it is stateless, and for example, if client gets stream error, any kind of, so stream is closed, and if client is trying to reestablish the stream, so it will be a new one.
Yeah.
And it also doesn't guarantee that server will know that the stream was interrupted by some error.
Yeah, I see. For that reason, I suggested trying out this middleware. As I mentioned, if you try retrying from the application side, like if you just create the stream again, if you invoke, in our case, client.gamble again, then you have to start all over again, definitely. But if you're able to intercept the error in a middleware, I think you have more control. The other thing which it might be worth exploring is whether there's some other thing. I mean, so when you previously asked this, when I was exploring, I did discover this gRPC middlewares. So that's why I suggested it. But there might be some other solutions as well. Have you tried a middleware solution, by the way?
Not yet. So currently we are not using streaming. So it's just the question, because we're here checking the stream. So, and I'm already faced with this unavailable error. So I'm just trying to compare expected behavior.
Yeah, I see.
And also maybe another note which is lacking this hands-on is just validation in Proto. So I think that validation rules are pretty commonly used in Protos. So because I can just, for example, withdraw a negative amount of money and I will have big.
Yeah, definitely. I mean, this specific application we're building, it can definitely benefit from more validations, but I decided not to include it to keep things simple. Now seeing the progress of everyone's almost done by now, I think that next time I attempt it, I might enhance it a bit. There were also some other suggestions I did receive from people who reviewed the workshop before. One thing was, for example, exactly using these kinds of middlewares for, let's say, authentication. So in our system right now, we have this user, but it's totally not an authentication at all. So in a more of a production setting, it can the examples can definitely benefit from some kind of authentication middleware, for example. So yeah, I do agree that it can definitely be enhanced with certain things. All right. So how is everyone doing by now? We have 20 minutes until the end. Actually, before that, Ivan, would you like to discuss anything else or have any other questions?
So I think I'm good now. Thanks.
All right. Nice. Oh, it's cool that people can change their answers. That's nice. All right. One thing which was raised in the beginning from Jeroni was about convincing teammates about gRPC adoption. Like, Jeroni, would you like to share a bit more about your case and what you're interested in?
Well, yes, was more like general questions. So what are the pros and cons? So, and also anticipate a bit what the cons of the adoption of gRPC instead of an API REST system could be for the organization. So to say, it's something internal of the organization. So it would be like APIs for internal use, and also like to anticipate what could be the future. So would be like more widely adopted of the solutions.
Yeah. All right. So, well, first off, more in a more general sense, similar to the question, I'd say that it's important to understand like the value proposition of, in this case gRPC, but anything really one wants to propose to the organization. But also, apart from the value proposition, understanding the cost associated with it. And that's probably a harder thing to do, because often when you read, let's say, about gRPC in their site or whatever, they don't really tell you about any cost. They just outline the benefits of using it so that you're eager to adopt it. I've noticed that this leads to I recently heard a nice terminology about it, like design by Buzzword or Buzzword-driven development, let's say, where you encounter this nice-sounding technology which people seem to adopt, and you adopt it because you follow the trend. I don't think that's necessarily a good approach to follow in general, not only about gRPC, because I'm not really a believer in, let's say, best practices or, best technologies. I think that different technologies have different use cases, and sometimes something which is simpler, older, and works can work better than the most shiny thing out there. One vivid example I have is, let's say, microservices. Here in Bulgaria, for example, what I'm noticing is that there are a lot of companies which have microservices in their, architecture, and yet they don't really need microservices. Like, they don't have the amount of users which would demand a more sophisticated solution like microservice-driven architecture. And at the end, what they are doing is just incurring additional cost without sufficient benefit from it. Because there is benefit to using microservices in the specific examples, but you won't be able to see it if your domain, your clients, your use case doesn't meet sufficient, properties, certain properties. Same goes for gRPC. I think the main, so transitioning to the concrete scenario for gRPC, I think the main thing which typically organization has to decide is that, let's say you've been using REST APIs for several years, you already have services which are using REST APIs and they're working well. They're in production and everything. And now you have the opportunity to transition to gRPC. And I'd guess that definitely transitioning, if you can click a button and make the transition, you definitely have benefits. Most likely, let's say. But unfortunately, it's not as straightforward, because you can't transition with a click of a button. You'd have to spend development time and introduce certain risk during the migration, because first it will take some time to migrate all your services to gRPC, regardless of how good of a technology it is. And second, while migrating, you risk raising incidents which might hurt, might bring monetary damage to your organization or brand damage or whatever, depending on what kind of domain you're working in. So that's the cost, I think, which is most prominent to consider. In terms of the benefits, I think the main selling points of gRPC, which might drive a migration, might make people adopt it, is first the fact that it's more optimized for certain scenarios. One of its greatest benefits is its very nice serialization via protocol buffers. I think protocol buffers compared to JSON is a very big win in terms of the amount of bandwidth you're saving. However, seeing the benefits of that, feature does demand that your applications, let's say, process sufficient amount of data. If your requests don't have that much data, they have, not so much of a payload. They don't have enormous, gigantic payloads. I don't think you would benefit that much from using protocol buffers. On the other hand, if your servers and clients are very serialization heavy, then definitely this might be something which might benefit you. The other thing is the fact that with gRPC you can have all those streams, whether they're unidirectional or bidirectional, out of the box natively. I think this is really useful and not something which is a given in other kinds of protocols. For example, at Uber, that was one of the main points which drove the organization to consider migrating to gRPC. At Uber previously, it was using a different RPC scheme called Thrift and T-Channel. It's still using it. Most services still use it, but they're slowly migrating to gRPC. And one of the main driving points to trigger the migration was the fact that with that RPC protocol we were using, we didn't have sufficient support for streaming. While with gRPC, you do have it. In our case, that was something which was useful. Now, in your case, will it make sense? It depends on the kind of use cases you have. If you don't need streams, if you are perfectly fine with RPCs, like normal request response RPCs, and you don't foresee a need to have a streaming API, then perhaps it doesn't make sense to migrate just for that purpose.
Yes, thank you. In our case, it wouldn't be migrate because it's like designing something new that it doesn't exist yet, and we don't have like a big like payload, or we don't need like big performance. But I hope that maybe there could come some benefits from using like a more strong typed way of communication instead of JSON, and also maybe that we could save some work of like validation, designing new APIs if we can like make use of the protobuf and then like to use direct like functions of every languages, because we're using different languages, programming languages. This was the part. But I saw there are also other questions that people wrote on the chat. So
I see only one. I'll get to that. To address your comments, in your case, if you're starting from scratch, let's say, then I guess the main selling point would be the fact that you have the clients and the servers, well, mostly the clients make the most impact, generated for you. So as you saw in the workshop, you didn't bother writing a library or a class or a package which knows how to communicate with the gRPC endpoints. You had that generated for you and you use it out of the box. With the REST API, you don't have that benefit, and you have to write client libraries all the time and have to maintain them and change them. So this can, using gRPC out of the box, can reduce the development time you'd need to start integrating with gRPC servers. So I think that would be a good point to point out if you're discussing it inside the team.
Yes, thank you. I also think that's a good point. I will go for it. Thank you.
All right. So can you recommend graphical user interface clients for gRPC? To be honest, I haven't used one. Interestingly, I haven't. So I haven't needed one because I typically rely on command line tools, like from here. So even with HTTP requests, I tend to use curl. So not the right guy to recommend any kind of graphical user interface tools.
I have another question.
Yeah.
Just a sec. There's my construction site right here. Yeah, there is a construction site. There's a lot of noise, but I'm gonna ask it quickly. Is there like we're using some gRPC in my team, and I'm new to that, and I saw that we have a script very similar to the one in the exercise that generates using Proto-C. And I've noticed that when I generate it locally and another teammate does it, we get different files in the end. So I wonder how can we standardize it, or maybe if we can even use a POM file if we're using Maven.
Yeah, I see. So I think that the differences are coming, they can come from two different things. One is the version of Proto-C you're using. The other is the version of the Go plugins you're using for Proto-C. In our case, we were using one, which was, I forget what was the exact name. Yeah, Proto-C Gen Go gRPC or whatever. You might use in your team some other plugins as well. Not necessarily that. This isn't necessarily the only one. So in this case, I think what makes sense is to, first, depending on the size of your organization, and based on what kind of things you can fund, you can handle it in different ways. I think one way which it might be handled, and we handle it at Uber, for example, is to have your own repositories for anything which you're downloading from the web. For example, for the Go packages, instead of when you use GoGet, instead of fetching it directly from the internet, you can fetch them from your own repository. You can set it up in a way that it first asks your own, repository for those files. And in your repositories, you can set them up in a way that you have certain versions that are pinned, so that you don't always use the latest version. You have, let's say, version 3.1. Even if the actual library goes to 3.2, 3, 4, etc., you can choose to, migrate to it once, your team decides that it makes sense. We use this approach for most, package management kind of software, not only for Go packages. For example, for Brew, I mean this one, I'm probably not saying it correctly. This is the package manager for Mac. We also have our own repository where you're installing packages from it first before accessing Brew packages from the internet. Same for NPM and same for other kind of package managers. That's one thing you could consider. The other thing also, which is a viable option, which solves a similar approach, is using Monorepo. That's essentially one of the main selling points for managing different versions across different environments. When you use a Monorepo, you can have a folder which has your dependencies, your third-party dependencies in there, and configured and everything. And all the teams or all the projects or all the teammates who use the Monorepo will always use those third-party packages. And if at some point you decide to migrate to a new library version, you won't just migrate 2 out of the 5 projects you have. You will be able to migrate them all at once, which avoids technical debt incurring over the long run. But that also has some costs associated to it. It's not an easy undertaking. So, but it is a good thing to explore if you're curious and interested.
Great.
Thanks. I was just not sure if Maven is possible.
Sorry.
Yes, sorry.
Sorry. Hi. Great discussion here, but we're a bit out of time. So, Preslav, I would appreciate it if you could summarize, and then we could continue having this discussion on Discord.
All right, nice.
Sorry.
Thanks, David. No worries. I did notice that we're out of time. So yeah, thanks everyone for joining the workshop. Really happy to, as David suggested, continue on Discord. I also share all the materials there and my email if you want to follow up. Thank you all for attending. Hope you enjoyed it. You learned something new. You practiced using gRPC a bit, and you can now make the case for migrating to gRPC easier in your own organization. So thanks a lot. It was a pleasure and honor, and I'll be seeing you. Bye-bye, everyone.